Hello. Just confirm to me in the chat if you can hear me well, so then we can start our stream. Can you confirm that you hear me well? I just need to check before we start streaming. Okay, perfect. So first of all, before we start, I just want to apologize because I had a technical issue. You know, like every time we try to demonstrate something for the client, something is not going well. All right, so first of all, if you're new to this channel, just go ahead and click subscribe button, enable the notification button, because we will be doing live streaming every week. So every week we will talk about a topic, we will do live coding, we will implement so many applications and so many stuff live. So it will be live coding. So just go ahead and hit the subscribe button, and especially enable the notification, so the notification bell, so you won't miss anything. All right, so first of all, let me talk to you, or like give you a heads up about what we will see today. So also, like, just go ahead, I want to know from where you are following me, just comment out. First, like how this stream, or like what we will do in today's stream. So first, like, we will do a deep dive into the microservices world. So we'll start like from Monolith, how to migrate, on like why we need to migrate, or sometimes why it is required to migrate to microservice application. Or a microservice architecture, and then we will talk about the different patterns, how to decompose an application, what are the different services that are required when you want to implement your application, or your Spring Boot cloud, or like your microservice architecture under Spring Boot cloud. So I will tell you all about this. And of course, we will talk about security. We will talk about synchronous communication, asynchronous communication. We will talk about security, how to secure an application, or like a microservice architecture based application. So we will do all that. And finally, we will have like a really amazing session. So it will be a Q&A session. So if you have your questions, just leave them for the end of the stream. So then, like, we will have a live interaction, and like all the messages will be displayed in the stream, and we will have a nice chat and a nice talk together. So yeah, I guess now we are ready to go. So the first part I want to start talking about in this stream is the migration, or like what are the reasons, or like when we need to migrate from monolith application to microservices based architecture application. So the first thing, first let me check the chat if someone needs anything, or so I assume that you hear me well. Right. So I guess everything is fine. All right. So now I guess we can move to this one. Just all right. So now when we talk about an application, generally speaking, so like when we talk about an application, so we have our application in this way. All right, so this is our application, okay? Or maybe let me make it this way. So this is our application, and in this application we will have some modules or some domains. All right, so we'll have module 1, module 2, module 3, and module 4, 5, and so on and so forth. So this will be 2, I don't know, like 3, 4, and 5. All right, so far the application is doing well. So this is a monolith application. So monolith application. So here with this monolith application, let's assume that everything is going fine. And here we have, let's say we have around 20 developers working on this monolith application. So here, like from my personal point of view and my personal opinion, here there is really no need to move from monolith application to a microservices application, because when we talk about microservices, we have like ups and downs, and we have like the pros and cons for a monolith application and as well as for microservices applications. Also, like I watched few videos and few people talking and saying that microservices sometimes, or at some point of time, it might be a technical debt. So this is a different topic, and I would like to talk, or like to dive in deep into it. So why microservices can be a bad choice for your application, but we will leave that for a different stream. All right, so now let's say that we have an application, a monolith application. We have 20 developers working on it, and let's assume that we have a decent number of users working on the same application. Like users, I'm talking about the end users. So this is totally fine. Now let's see the reasons, or like when we need to think about migrating from monolith to microservices architecture. So the first thing, let's say that we have the module number 5 receives, let's say, I would just give random numbers. So it's not like, it should not be this way, or like it might not be this way. I will just try to give some random numbers. So let's say this module 5 receives 30% of the traffic on the application. So for example, when we send requests, like 30% of them are going to module number 5. And let's say, for example, this one is 10%, this one is 5%, this one, let's say, another 10%, and so on and so forth. All right, so here, and let's say, for example, maybe this one is receiving 40% also of the traffic. So here, what we need to do, so for example, like in case the number of users is increasing and the number of demand on the application is also increasing, what we need to do in this case, before even like moving to microservices or anything else. So what are the solutions here? So first, or like the first solution, is to do a scale. So like what we can do, we can scale up the application. So like when we talk about scale, so here we can talk about different types of scales. So like we can do like whether we increase the number of instances of the application. So we can have like 3 instances running, or like we can have, for example, 2 instances with higher resources. All right, so like 3 and 2 is just an example. So like this will be an instance 1, instance 2, and this one, like it will be 1, 2, and 3. All right, so this is one way of doing that. All right, so this is one way. This is one way of doing this, or like upscaling the application. So this here, so like we will require some few things like load balancing. We need also like a synchronization between these different instances with a database, and so on and so forth. So this is the first case. So like scaling up might be a good solution for us. So like we don't need to migrate our application from monolith to microservices. So here, if we say that scaling up the application solves the issue and all the customers, or like all the end users, are satisfied with the application and like the output and the response time and so on and so forth, so we assume yes. But now let's talk about a different use case or a different situation. So scaling up the application, we can see, or like we can notice with the monitoring, we can notice that we have as we mentioned here, like we might have load on only 2 modules. All right, but scaling the whole application, like having 3 instances or like even more instances, this like increases a little bit the budget, or like the amount of money that we need to pay in order to have this scale up. All right, so then when we so like the second option is maybe just to change to a different architecture of our application. So this one reason, so like when we have different loads on the application, so like we have like 40% on one module and 30% and on another module, so like they receive a lot of load, but the other modules, they don't have a lot of load. All right, so then what we can do, we can check, or like we can see a different option. So this is the first reason. A second reason, let's say, for example, with new customers, like we always have new features. All right, so here let's say that our developers, or like the number of developers, is increasing from 20, let's say, to 100. Okay, so now we have 100 developers within the company or the team. So like a team of 100 is too much, but it's, let's say like we have different teams and the whole company has 100 developers. All right. So now one problem that we might notice here when we have an important number or an important number of developers working on the same project on the same code base. So here, when we want to release a new feature, for example, so when we want to release a new feature, we might have, or like, let's assume that we want to release a feature on the module number 3. All right. And this module number 3 needs, or like has a small dependency with module number 1. And let's say, for example, module number 3. All right. So like here we have some dependencies. All right. So these dependencies, like we might have a blocker right here. So like the team which is working on this module needs to wait for the other team which is working on the module number 4, and so on and so forth. So this will create like a train of commits, or like a train of changes that blocks one team from just being 100% independent to release different features. All right. So this also might be a reason to migrate from Monolith to microservices application. All right. So here, now let's see the reasons, or like the pros or like the advantages of moving to microservices application. So I will scroll a bit down right here. So now let's start. So first we will have like different teams. So let's say, for example, we have team 1 working on the application. We have team 2 working on a different part of the application. We have a team 3, and so on and so forth. So first, like, we can have multiple teams working on different parts of the project in an independent way. All right. So like we don't have or like every team is responsible of a feature of the application, or a module, or a whole module, or a whole domain of the application. So this is one reason. So the second one, as we mentioned here, so we know that we have a module 2 which receives a lot of requests comparing to the rest. Also module number 5. So what we can do also, like, we just need to scale up this module and scale up the second module. So like we need to scale up only 2 modules just to ensure that the application is working perfectly fine and we don't lose resources. And also, like, we don't need to reserve or like to buy extra resources, extra let's say virtual machines, or like machines just to run the whole application, because we just need to scale up just for 2 modules, or like 3 of them, depends on the size of the application. All right. So here, like, we see now that based on the number of developers of the application, we can decide whether to migrate or not. Also, another reason of using microservices, like, so now I'm talking in a general way, or like in a global way. So when we move to microservices architecture, so here we can say, for example, that team 1 can use Java for the code. Team 2 can use, for example, PHP. Team 3 can use so and so forth. So like first, like, we will have a diversity of skills within the application, or sorry, not the application, but within the company. And each team can decide what is the best technology or the best programming language that they want to use. So for example, we might have another one with Python, and so on and so forth. So this also an advantage of using microservices architecture. So here we spoke about maybe the few reasons why we want do you still hear me? Because I see maybe that I have an issue. Can you please confirm in the comments if you hear me, if you're still receiving the stream? Okay, perfect. So yeah, because I had some strange pop-up saying that the stream is not going well. Okay, perfect. So let's go back now and continue from this point. So now we saw, or like we discussed few reasons why, or like few reasons that might help us deciding whether we move to a microservices architecture or not. So now how to move how to migrate from a monolith application to a microservices based architecture. All right. So first we have few patterns that we need to discuss. So let's discuss the first one. So the first pattern is called DDD, or like domain driven design. So here I will just type it, domain driven design. So this DDD, or the domain driven design, is based on like few rules. So like I will not go really deep in that, because even domain driven design is a whole area of discussion. But I will talk to you about few things that you need to consider when you want to move to or like to apply the domain driven design, and why you need to apply the domain driven design. So here, going back to our monolith application. So here in our monolith application, we just identified, or like we said, we have 5 modules within the application. All right. So here, having 5 modules means that we can divide, or like we can split the application or the monolith application based on the domain. So here, like each domain might be, or like we might call it also a module. All right. But it will be an independent service, and we will talk just later on about the architecture of that. So here, let's say, for example, we have an application. And let's say whether an e-commerce application or any other type of application. So here we can say, for example, we have a domain 1, we have domain 2, and we have domain 3. So this part, like discussing about the domains, is not something technical, but it's purely functional. All right, so here what we can say, or like what we can decide. So here we have a domain 1 which takes care of customers, like the different customers of the application. So here we have customers. We have another domain, let's say orders, for example. We have something else, or like we have some feature and functionalities that takes care of any kind of notifications. So like email notifications, real-time notification, SMS, and so on and so forth. So like any type of notifications. Let's also say that we have another one, which is product. So like a product domain. And here I will just add something else. So I will say category right here. So like each product has a category. So like I would just say this one is domain 4 and this one is domain 5. All right. So here, when we want to split the application, what we need to consider is the following. So here we need to discuss, like with the stakeholders, or like with the people who are taking care of the functional side of the application, what are the different domains and what are the main area, or like how can we split our application, or like the global idea of the application, into small services based on some common areas or like some common properties. So here, when we say customers, for example, we can have an application or a microservice which takes care only about customer, like saving a customer, retrieving the data, updating the customer data, and so on and so forth. The same for order right here. So like order, we just receive a product or a list of products, and for a specific customer with a specific amount, specific price, and so on and so forth, we just do the calculations, we do some stuff, and then we just push or like save the data, and then we notify. And then, for example, let's say here we have also, let's also say we have a stock microservice, or like a stock domain, and this domain takes care about updating, or like let's say this D6, for example, and this domain takes care about managing the stock, the also like the inventory, and so forth. All right, so here how we can decide how to split our application. All right, so this is the first part. But here you need to pay attention about something. So like I will just come back to it later on. I will just put here, or like this part, into a red square or a red area, and I will come back to this right now. So the first thing, or like the first part that we spoke about, is the domain driven design, or like the DDD. All right, so like this is a way how we can split our application. All right, so then after DDD, so like one of the patterns, which is called a database per service. So here we talk about a database per service. All right, so we need here, when we talk about microservices, we need a database per service. So why we need that? All right, so why we need a database per service? So here, let's imagine that all these microservices that we have right here. So let me maybe draw something new. So like we have microservices 1, microservice 2, microservice 3, and maybe 4, for example. All right, and here we have our database. So because let's go back to the first drawing. So like one of the advantages also like of having microservices is that each microservice will be running in an independent way. So like we don't have any other dependencies. Just in case, for example, just in case one microservice goes down, the whole application is still working. So like the whole application still works in like in a fine way. Or like, let's say, for example, we have one feature which is not working, but we have 80% of the application which is working. So like we have, let's say, for example, that we have a group of users. So like assuming that we have within our application, we have 100 connected users at the same time, but only, let's say just only 10 of them are using this microservice, but this microservice is down. And we have 90 users using the rest of the application. So like here we have 90. So 10% of the users of the application will be blocked because one microservice is down. So like we can later on just start it again, or like check what is the problem and like start the application, or like restart the microservice within few seconds, milliseconds, and so on and so forth. But what we gain again is that we have 90% of our users, they will not be blocked at all. So like they will be able to continue working with the whole application, except if they need this module which is currently down, assuming that. All right, so now this is one thing I wanted to discuss about. So like also another advantage of using microservices. Now let's go back to this topic, which is a database per service. So now imagine like all our microservices, they are all of them connected to the same database. All right, so the first thing that we can notice is if this database goes down, the whole application will be down. All right, so like this is not something that we want within our application or within our architecture. All right, so like the whole application will be down. So there is honestly, like I don't see any advantage like or any reason to moving from monolith application to microservice application, because here we just come back to the same one, having one database connected to our microservice, to our monolith application right here. The application, the database goes down, so the whole application also goes down. So now that's why we need something, or like we need a database per service. All right, so maybe let me clean up a little bit here. And now let's talk about a database, or like why we need database per service. So here we have this one having its own database, this one having its own database, this microservice having its own database. So here in the same way as we explained before in this part, I just forgot where, I think it was right here. But here, if for example, if this database goes down, so only this microservice or this part of the application will be down, but the rest of the application will be working fine. So like again, we go back to the 10% and 90%. So like 10% down and 90% up, or like are able to use the application, which is something good and which is something that we want. All right, so here the thing that I want to mention in here, and why I had this red area or like red rectangle or circle, like I don't know what this shape is, but here, so I will just try to go back to this domain driven design. So here when we talk about a database per server, so let's say here, or let's try to assume that product, category, and maybe stock. So like maybe let's start with just product and category. Assuming that product and category, both of them use the same database, which might be fine. All right, so like not the whole application or the whole microservices, they are using the same database. And here, by the way, I want to mention, when I talk about a database, we talk about a completely virtual machine dedicated for a database. All right, not just having one instance of, I don't know, like Microsoft or like MySQL or like Postgres SQL, and within this one we might have different databases. No, I'm talking about a complete virtual machine having its own database running on that virtual machine. All right, so like I just wanted to clarify and highlight this point. So here, assuming, let's go back again to this part, assuming that product and category, both of them, they use the same database for one reason or another. So which is here, like from a logical way, we might say this is fine. This might be fine. That product and category, they use the same database, since here we talk about this almost the same thing. So like a category belongs, a product belongs to a category, and the category has multiple products. But the thing is, when we want to apply the domain-driven design, what we need to do in this case, we need to merge these two parts. All right. So like these two domains or these two microservices, they need to be, or like it's better. Let's say, okay, so like I won't say they need to be or like they must be, but they need to, or like it's better. So like I just said it again, but it is better that these two domains or these two microservices become only one microservice. Let's call it, I don't know, like product and category, product, and so on and so forth. So like the naming is not something important in for today. So like we are not talking about namings. So here, if, as I mentioned before, if two microservices or two domains, they need to communicate within the same database, what we need to do, we can here just merge them. All right, so like we can have one domain or one microservice for both of them. But here, just in case, let me put this in red. So here, let's say in case we have one microservice here, or like a domain number 7, for example, which needs like an information, or like needs to read from a table or write into a table that in a database that belongs to a different microservice or a different domain. So here we need to raise some questions. All right, so like, did we correctly apply the domain-driven design, or there is something wrong within our application? All right, but if, for example, just this domain 7 or microservice 7 needs just to communicate in a normal way, like HTTP, gRPC, async way, and so on and so forth, so this is perfectly fine. But if we have a need just to update the database from a different domain, here we need to raise a question. All right, so like here we need to say, okay, what's going on? Did we made something wrong or what? Okay, so this is something that you need to consider. All right, so I hope this part was clear. So like moving, or like maybe some reasons why we need to move from microservices to from monolith to microservices architecture, domain-driven design, and also like the pattern database per service. So here we will continue within the rest, or like the other different patterns, and also like how a global architecture might be, the different ways of communication, how to communicate between different microservices. But I just want to have just a short chat session with you, and just I want to see if you have any questions. So like now you feel free to ask questions, and by the way, the question will be displayed in the screen, so like in this place right here, with the name and with the message itself. So like I will try to start reading your comments right now. All right, so like just go ahead and drop your message. So here I see one question. So like, what if you want to have JWT? So like about security, I will just talk about it later on. So like it's also part of today's session. So like I will just talk about it in a few seconds. So like if you have other questions, please go ahead. Saksham, so what are we building? So like today it's not we are not building anything, but I just wanted to dive deep, or like theoretically into the microservices architecture, why we need it, why to move to microservices, what are the reasons, the pros and cons, and so forth. So like this is today's session. All right, so like other than that, if you have other questions, just please go ahead. All right, so if you don't have other questions, I guess we can move on to the other part. Okay. All right, so here I see a good question or an important question. So here, someone is asking, like, I think database per service is a harder stuff. Most of the times, it's better to keep one database per business block or logic. So here we just go back to the same topic that I just explained in few moments ago, is if the database goes down, all the domains, so like just to stick to your question, all the domains will be down. All right. So this is a downside of having one database for multiple services or like for multiple domains. So like one, I know like microservices, when we talk about the cost, microservices might be costly. All right. But for example, like for applications like, I don't know, like Amazon or like an e-commerce application or something like that, it might be really, really helpful. All right. So yeah. All right. So here, all right, so here we have another question. If a service have multiple controller mapping with service like API product and API category, then how to define API gateway? So here, I'm not sure if your question is about this, if you are talking about the same microservice or like you are talking about two different microservices and how to do the routing. So like, even if it's the same microservice, on the API gateway, you can just create a new route, and what is the pattern, or like what is the match for that one, and you can redirect many requests to the same microservice. So like, it's totally fine. Right. So I think also like in my microservices application, or like my microservices video on YouTube, I also covered this part. So like, you can go ahead and check it. All right. So now I will be a little bit picky about the questions, and then I will go back to them later on, because I just want to pick questions about the parts, or like what we just spoke about. Just I wanted to clarify anything, or like something if it needs to be clarified before moving forward. All right. So like API gateway, the different services and patterns, we will just talk about them in few seconds. All right. Okay. So I guess now we can go back to our mainstream. All right. Okay. So please let me know in the comments if my video, or like my picture right here, is hiding some part of the chat. Just let me know. I would like to know. All right, so now we spoke about 3 topics. Why, or like what are the reasons, or like when we need maybe, or like when we need to consider moving from Monolith to microservice, and if we decide to move to microservices, what is the first thing that we need to apply, which is DDD, and then we spoke about a database per service. But here, just as I mentioned, like having a database per service is really beneficial, or like has a lot of advantages. But if you decide to have one database for the whole application, or like grouping multiple domains within the same database, just leave with that if you have any issues. All right, so now what we will see next, let's first like discuss, or like what are the different services that we need when we want that we need. So here, like this part, just I want to mention that. So here we are talking about Spring Cloud, Spring Boot, and Spring Cloud, because here a lot of parts that we can, okay, I will explain just in a few seconds. So here, let me finish this one. So what are the different services that we need for a microservices architecture? All right, so now we will start explaining these parts one by one. All right, so here we just as I mentioned, we are talking about Spring Boot and Spring Cloud. All right, so too big. Okay, so here, let me go back. And now the first thing, or like one of the important things and one of the important parts that we need to consider when moving to microservices architecture is here we have something which is called externalized configuration, or like externalizing configuration. So here we mainly talk about a config server. All right, so like we want to have a config server. So why we need a config server? So now we have, this is our configuration server, and we have here a microservices 1 and another microservices 2 and 3 and so forth. All right, so like I would just microservices n. So now we need, or like each microservice or each application, because here when we say a microservice, it's simply a Spring Boot application or any other language. But here within Spring Boot and Spring Cloud, we have a microservice, and within this application we have some properties. All right, properties or configurations. All right, so like configurations like another service URL, how to connect to the database, how to, or like maybe some secrets, some API keys, and so forth. So here, why we need, or like why we have this config server within this architecture. So here, the first thing is, imagine that I want to do some change here. So like I want to change from 1 to 2, all right, or from A to B, all right? So I want just to update one property. What I need to do, I need to redeploy the application. So like first push it, and it needs to go through the pipeline, through the different steps, running the tests, deploying the application, and so on and so forth. And then I need to restart this microservice. Okay. So when restarting the microservice, I might include a downtime. A downtime. All right. So, okay. So let's even just forget about that. It's not a problem like having a downtime when we restart an application or a microservice. Let's say, okay, it's acceptable. But here it's just a configuration that we want to change. So for example, I want to send a request, or like I want to notify from, I don't know, endpoint A, I just wanted to change it to become the endpoint B. So here, instead of just redeploying the whole application, all I need to do is just to have the change within my configuration server right here. And within this configuration server, it will be, or like this microservice will be automatically notified. So here I will have a notification. Well, it's a kind of, it's not exactly a notification, but this microservice, let's say just in a different way, I want to explain it. So this microservice is subscribed to its own configuration, which is stored on the config server. So when something changes here and we redeploy the config server, so this microservice one will know that something has changed. So I will pull the new configuration. So like we don't need to restart all the microservices. Let's say, for example, we are changing one property which is commonly used for within, or like from the different microservice. So like here, imagine that we have just an example. So here, imagine that we have 15 microservices running at the same time. All right. And I want to change one property which is common, or like which is used by the different microservices. So I want, or I need to restart all the 15 microservices. But if I just change it in one place, I need only to redeploy this microservice right here, or this server right here. And all the microservices will be able, or like they will get a notification. So they will pull again and they will update this property from the config server. All right. So, all right. So like this is the first pattern, or like the first part that we need to talk about is externalizing the configuration of the different microservices. All right. And also like here we can have different staging, or like different environments, like properties for dev environment, local, and so forth. So like all that will be stored in one microservice. All right. So this is the first part. Then the second one, all right, I want to check if we have some messages or something like that. All right, will you have demonstrate all of them? All right, so no other questions, but I promise when we move to the Q&A session, we will discuss a lot of things. I will answer also like all your questions. All right, so here, just after talking about a config server, we need something else. All right, we need something which is, okay, so it's known as a discovery server. So I'll just type it here. So it's a discovery server. And what is this discovery server? So this discovery server, so it's something right here. And now I will move this one down. So a discovery server is here each application, when the application starts up, or like when the application runs and it's up and everything is fine, this application needs to register in here. So like here, I want to register myself. So like this microservice 2 is saying I want, or I need to register myself into the discovery server. And in the same way for all of that. So like, then I will tell you why we need this discovery server. So this discovery server we will have different instances, or like the different microservices are registering in here. All right. So now after this one, we will talk about another one, and then I will relate to the discovery server. So here we need to talk about our API gateway. So here API gateway. All right, so this API gateway, so here there is one thing which is very important. So all these, or like all the infrastructure or all the different microservices, they need to be part of a private network. Sorry for the drawing, I think it's bad, but it's okay. So here, this one should be a private network. So a private network means that no one from the outside can access a single microservice in here. So for example, if you type the, I don't know, like the main machine, or like the main URL slash, I don't know, like slash product slash get slash one and so on and so forth from the outside. So like you will not be able, even if you have the correct address, the correct IP address and so on and so forth, you should not be able to access this one. All right, you should not be able to access one microservice or another. You should always go through an API gateway. All right, so let's just say it in a general way. You should go through a gateway, because within this gateway we know which microservice, or like to which microservice, or like with which microservice I need to talk. So like here we have an HTTP request, and this one, it will dispatch the request to the dedicated microservice. All right. All right. So here, just 1 second. I see something in the chat, I guess. So guys, just as I mentioned, I will answer all of your questions. So don't worry, we will start our Q&A session just after explaining all these topics. So, so like, I will answer all your questions. All right. So like, I will try just to move away the chat because sometimes it's just distracting. All right. So now let's go back and talk about this API gateway. So here, as I mentioned, why we need an API gateway. So like, okay, maybe you say, okay, I want just to access my microservice and I don't need to go through any other application or any API gateway. So here there is something which is very important. So now when we spoke in the beginning about the advantages of microservices. So let's say here for this microservices number 2, I want to have a second instance, a third instance, a fourth, and so on and so forth. So like I'm scaling up my application. So I have different instances, and each instance will be running on a different port. So like here I will have port 1, 2, 3, and 4. All right. So here, when I want to send a request, I don't know what is the port of the application. So, okay, I know the address, but I don't know the port, because when we scale up, it will, so let's just explain it in this way. So like when we do a scale up, we will start a new instance, and this new instance will have a random port. So I don't know the port of the application. So it's kind of impossible to connect to, it's kind of impossible to connect or to reach out this application. All right. So now I will just go back to the discovery server, and you will see now the importance of this discovery server, and then we will link up and we will come back again to the API gateway. All right. So now each microservice, when we scale up, so each instance will register also in this discovery server. All right, so like each instance needs to register in here. So we might have microservice 2 with instance 1, instance 2, instance 3, instance 4, of course, with the port right here, and with a bunch of information if the application is up or down, and so forth. All right, so now we mentioned here that we cannot and we should not access any instance or any application or any microservice from the outside. We need to go through an API gateway. So what will happen here, this API gateway will connect also to the discovery server. But in this case, the API gateway does not need to register, but it needs to pull the information of the different microservices that are running right now. All right, so that's why we need a discovery server. So like, because our API gateway needs to know the different microservices and the different addresses, ports, if the microservice is up, down, and so forth. So now our API gateway already has the information about the different running microservices. If one microservice goes down, also we will have, so like, because you see here, like it's a two-way arrow. So so like we have two ways arrow. So like API gateway will connect to discovery server, and if something changes or like gets updated in here, the API gateway will be notified immediately. All right, so now what we need to do, so like let's talk, or like let's see how to dispatch the requests. So here we said that the API gateway will send a request. So like the API gateway has already the list of the servers with a route and a pattern. So for example, if I want to reach, just an example here, so if I want to go to /API, I don't know, like maybe /v1 for example, /products, just to retrieve the list of products. And here, let's say this M2, or like this microservice 2 is the product microservice. All right. So here we know, or like assuming that we have a lot of load on this microservice 2, that's why we did a scale up, or like that's why we scaled this application. So now here the API gateway has a load balancer. So this is also something very important. So a load balancer will try to load balance, or like will try to dispatch the different requests to the microservice, or like to the source, to the destination, based on the traffic. So for example, like we have, let's say here we have 5 instances. So let's say this one is 90% occupied. So like the API gateway will send it to this one, which is, for example, only 10% occupied. So the API gateway will dispatch the requests through the different instances that we have for, or like within our application. All right. And if, for example, one instance goes down, the API gateway will consider that, since here, let's say this one is down, and the API gateway will get notified, and then he will no longer consider this instance number 4 or number 5 to be part of the destinations to send a request to. All right, so this is also the importance of the API gateway. So like here, simply we spoke about a config server, discovery server, and an API gateway. So I hope you got, and everything was well explained, I hope. And then, like, of course, I will answer your questions later on. All right, so now when we talk about API gateways, config server, discovery, and also discovery, config server. I hope I did not forget anything else. All right, so let's move to the next part. So also, maybe before moving from one part to another, we can also try to double check the chat. All right, so I will do that, and let's see if we have some comments or some questions. All right, so okay, so here I see a question. How did you handle communication between services, especially in terms of ensuring reliability, scalability, and fault tolerance? Please explain this. So this is like the next topic that I will explain. So like just stick around and I will explain it in few seconds. All right, so you have several microservices that need. Okay, so here I have another question. So wait, I think I selected the wrong one. Okay, so it's this one. So you have several microservices that need to keep data consistent across all services. However, due a network issue, a transition gets interrupted halfway, leaving some services with inconsistent. This is a really good question. And this is also like another pattern that I will explain it just after explaining the communication between microservices. So don't worry, guys, I will answer all your questions and I will explain everything. All right, so how can we notify microservice to reload config after we deploy config server? Because microservice, when they start, they take configuration. Yeah, this is a really good question. So here, because like when we use a config server, there is an annotation. To be honest, like I don't have it on the top of my head right now, but there is an annotation that you just need to add it on the top of the configuration or like in your application, and this one will know, or like we will do the extra work just to pull the notification from the config server whenever something gets changed. So like I will try to check it, and maybe in the next live I will try to cover it. All right, so but this was a really good question. Okay. Will this broadcast? Yeah. So this live stream or like this broadcast will be registered and, well, not recorded, but it will be available later on YouTube. So don't worry about that. I will also like check the quality. If the quality is fine, so like I will keep the video. Otherwise, if needed or if required, I will upload the recording to have a better quality of the video. All right. So. Can you sell this course in Udemy? Sorry, I didn't get the question, but coming back to selling courses, so like all my content will be for free on YouTube. Just if you want to support me, just feel free. You have the support link already in the video, like you can see it on the left bottom side. You can support me there. If you want to support, you can also like support on YouTube. It's up to you guys, but I'm providing free content, so like no need to pay money for that. All right. Okay, so now let's go back. Let's go back to our main stream, and let's go to the next topic. So the next topic that we will talk about is synchronous and asynchronous communication. So synchronous slash, oops. Communication. So like this is mainly like how we can communicate different microservices. All right. So here again we have microservice 1, microservice 2, 3, and 4. So like have 1, 2. Sorry for the writing. Maybe let me 2. We have 3 here, for example. So now we will start talking about synchronous communication. So first, let's explain what is synchronous communication. Synchronous communication means microservice 1 will send a request to microservice 2, and it needs to wait for a response from microservice 2. So like we need to have a response. All right. So like if just an example, if this microservice 2 is down, so this means also that the full or the whole process of microservice 1 will be failing. All right, or it will result in a failure. All right, so like this is what we mean by synchronous communication. I send a request and I need a response. All right, so it's just like for example, like picking the phone and calling someone. And when this person picks up, or like when you want to reach out to him because you need to inform him about something, so like you need a response from that guy. So like you need to ask him a question, for example, and you are waiting for a response. So this is synchronous communication. Now we will talk just in a few moments about asynchronous communication. So like how can we establish a synchronous communication between two microservices? So here we have several options. All right, so like here, let's maybe talk technically. So like first we can use OpenFeign. All right, so like OpenFeign is a library or a dependency. I think it's, yeah, initially it was developed by Netflix, and then it was adopted by the Spring, or like the Spring community, or like by the framework, or like the Spring framework. So here we have first, as I mentioned, OpenFeign. We have also REST template. So like we can use a REST template just to send HTTP requests. So like here when we talk about OpenFeign REST template, we are talking about mainly about HTTP requests. Or like we can just use a classic or a simple Java code with like just sending an HTTP request. So as I mentioned, all this is HTTP. All right, so like we are talking about HTTP requests. So other than for an HTTP communication, we can use, as I mentioned, OpenFeign REST template, or just Java, or like maybe there are other libraries that we can use. So right. Okay, so also we have different other different protocols, or like different ways to communicate between, like in a synchronous way, between microservices. One of them is like also RPC, or remote procedure call, or like it's called gRPC also. Yeah, so like HTTP, gRPC, and so on and so forth. So like this is the synchronous communication. Like I send a request, I wait for a response, and when I get my response, so like I just do whatever I need. If the service is down, so like this is also something else. So like, and here when we talk about synchronous communication, there is something. So I will just add a note, or like highlight this one right here. So I will just put as like two question marks, and I will explain what I mean in a few seconds. All right, so this is the synchronous communication, and now we can talk, or like we can move and discuss about asynchronous communication. So like what is asynchronous communication? Asynchronous communication is just I send a request and I don't need an immediate response. So like even sometimes we might say I don't care about the response. All right, for example, I just send a message, or like I grab my phone and I send an SMS to someone just to give him an information, but I don't care if this guy read the message or not, if he took action or not. So this is not my problem. So like this is one case, but it depends always on on the business side, or like on the requirement of the application. Like sometimes we need, okay, if I send a message in an asynchronous way, and if the other part is not able to react or like to receive the message, so here we are talking about an issue or something like that. But this is not what I mean. Like what I mean exactly is like I send a message, I send an information, but I'm not expecting an immediate response, okay? Or even I'm not expecting a response at all. All right. So here, when we talk about asynchronous communication, we mainly talk about, so we need okay. I just forgot the English word. I'm sorry for that. I was just going to say it in French. So like we need something in between. So something in between, like I need, for example, I don't know, like I need something here. So like, maybe let's just draw it this way. I don't know what I'm drawing, but I'm just drawing it this way. So I need something when I send a request from service, or like microservice number 2 to microservice number 3. And here I'm sending a message. I know that my message is stored somewhere. So my message is stored somewhere. And then the microservice number 3 will just connect to this thingy here, and we will talk about it just in a few moments. My microservice number 3 needs to communicate, or like to fetch data in a consistent way, or like regularly from this storage system, if we might say. and based on the message or the data that we will receive in here, he will just react. All right. So here, when we talk about this thingy, so like what is this? So here generally we are talking about a queue. All right. So here we're talking about a queue. Let me write it better. So here we are talking about queuing. I need to queue a message. So like a queue is something in this form. So like generally speaking, a queue is a data structure. So here I will have a message in here. I will have the second message in here. I will have a second message in here, and so forth. All right. And then, so like when I need to push a message, so like I would just push a message in here, and my microservice. So maybe let me draw it with a different color. So I will just put a message, and here this microservice will consume the message. So like it's just first in, first out. Like the first message will be consumed first. Like the first pushed message will be consumed first. All right. So like this is queuing, and so like this is how in a global way the data structure. So like we want to queue some messages, and then here also we are talking about a message broker. All right. So like brokers or message brokers. A message broker. All right. So let's make this one smaller. So here we talk about message brokers. For the message broker, we have many of them. So like we have known ones. We have Kafka, for example. We have RabbitMQ. We have also active MQ, and so on and so forth. So like we have several of them. So like we can use, depends on the needs of our application and the business requirement, the infrastructure, the budget, and all this stuff. We can choose one message broker and we can just connect to it. So like the idea of using a message broker is I just push something, or like I push a message or a notification to my message broker, and then this will be consumed from from one or multiple microservices, because here when we talk about a queue, we can have multiple queues, by the way. So like it's not only a single queue, so like we can have multiple queues. So like this is Q1 and Q2 and so on and so forth. Also like I can have, I don't know, like a microservice number 4, which is connected to, or like which is collecting or like consuming data from the Q2, and microservice 3 is consuming data from microservices 3. So like I can have the same broker with multiple queues, and I have multiple other services connecting to the same message broker. All right. So this is asynchronous communication, and this is really useful, mainly if we have, as I mentioned before, if I'm not dependent on a response from the destination. So I just need to know, or like I just need to push something, and I just need to inform about something. But maybe I like having an immediate response does not really help me, or like will not help me at all. So like, okay, an order was created. Now you can proceed to payment. All right. So okay, now I just need, you can proceed to payment. So like proceeding to payment, or like having a payment, I need a synchronous communication. All right. So like I need to know if the payment was successful or not. But I want to inform the customer that the payment was successful or not. So like imagine, or like assuming that we have a payment microservice. So this payment microservice will just send an email. All right. So just to make things faster, we just send a message, or like we just send a notification to a queue saying, okay, now you need to produce, or like you need to send an email for this specific customer with this specific information, and tell him that your payment has been successful, or your payment was failed, or like has failed. So in this case, I just push it to a queue, and then I will have, or like I can have a notification or another microservice that will consume this data or consume this message, and then this service will be the responsible one to send the email or to send a notification or an SMS, and so forth. So like this is what I mean, or like these are the use cases of synchronous and asynchronous communication. All right, so now we will move to this part right here. So like I did not forget about this one. So now let's talk about it. So again, I will just draw microservice 1, and microservice 2. And this is the answer for the previous question, which was, yeah. So like with the message, which was, so like maybe let me display the message again. All right, so like you have several microservices that need to keep data consistent across all services due to network issue. Transaction gets interrupted halfway, leaving some services with inconsistency. So this one, I think, yeah, sorry, it's not this one. I will answer this question just in a few seconds. So the question was how to handle communication between services, especially in terms of ensuring reliability, scalability, and fault tolerance. How to explain this. So like this was the question. Now let's go back to our drawing tool. So here, when I send a request from microservice 1 to microservice 2, so like I'm sending a request right here, but microservice 2 is down. All right, so like microservice 2 is not up, or is not working, or is not responding, just in a general way. So here we are talking about something which is very important within microservices, or like it's not just microservices. Sometimes we have things which are not only related to some specific architecture, or like to some specific technology. So here, what I'm talking about right now is having a circuit breaker. All right, so this one, or like this technology, or this pattern right here, it's not only microservice specific, but we can use it, for example, if we have an application that needs to communicate with a third-party API, and we need to handle the failure of this third-party or this downstream API. So this is the case. Now let's go back to our context, or our initial context, which is microservices. So I have a microservice 1 needs to communicate with a microservice 2, but microservice 2 is down. So for this case, I need to implement, or to put in place, a circuit breaker. And for that, what we also can use in here, so like we can use a library called resilience 4J. Resilience or resilient 4J. Sorry, I'm not 100% sure about the name, but this is a library that we can use in order to implement, or like to put in place, a circuit breaker. All right, so like now let's see what is the circuit breaker. So here, like in an easy way, as I mentioned, if this request is failing, so I need to have a kind of a rollback or a backup function, or I need to do. So assuming, for example, here I want to get the list of products. All right, so like I want to fetch the list of the products from microservice 1. Like microservice 1 needs to fetch, or like to get the list of products from microservice 2. But in that case, or like at this amount of time, or like at this timestamp, the microservice 2 is down. All right, so here what I can do, other than the circuit breaker, what I can do is implement, or like put in place, a retry system, all right, or mechanism. So a retry mechanism is something that I say, okay, now I have the request number 1. So like the first request has to make a second call. All right. So just here, let's say just wait 2 seconds and make, or establish, or like send another request. Then, so like we send the second request. Let's say also the second request is failing. So let's wait another 2 seconds and send a third request. So now the third request, let's say maybe the third request is success. So here's success, and we have our response. So this is one mechanism. The second one, we can also have, just assuming here that if the third request fails, so like we no longer need to wait, because a retry mechanism, for example, we just configure it to retry 3 times. All right, so like we can configure it to retry many times, or like more than 3 times, but 3 times is okay. So after 3 times, imagine like after 3 times here also we have another failure. So what we can do is we can call another method right here. So let's say, for example, just find, or like fetch from cache. Okay, so here let me just write it, just an example. So like this is a fallback, right? So this is a fallback. So here fetching from cache, so I will just go and fetch from my cache database like Redis or any other caching tool. All right, so this is the circuit breaker. So like we need to handle the unavailability of a microservice, generally speaking. All right, so we need to handle this unavailability. So like if a microservice is not available, I need to have a mechanism that first will allow me to retry. Second, because like why I need to retry. So here, let me just go back to this one before moving to the other topics. So here now what I'm doing on this microservice too, so like I'm redeploying. All right, so I'm doing a redeploy, so like I'm deploying a new feature or an update or something like that. So in that time, or like during this redeploy, microservice 1 is trying to connect to microservice 2 to fetch some data. But the redeploy, let's say it takes, I don't know, let's say it just takes 5 seconds, or let's say it just takes 3 seconds just to redeploy, which is, I don't know, we don't care about if this is fine or not. But here we need 3 seconds. So the first retry, we will have our 2 seconds. All right, so like we will wait. So like we send the first one. Let's imagine that sending the request and redeploying, they will start at the same time. All right, so like here in this case, I'm talking about this one. So here, let's say this is my time, and here I will start like sending request, and at the same time, so here I'm just doing deploy. All right, just to mention like that. All right, so like sending the request, it will take, for example, 1 second, and then I will just wait 2 seconds right here. And here redeploying, we said that it takes 3 seconds. So like it will be ending, for example, just in here. So like I send the first one, wait 2 seconds, and then I need to send the second one. So like it will fail. So like here we have attempt number 1, and this one is attempt number 2. So now we need to wait also 2 seconds, and then I will send a new request. So like when sending the new request, so like the system is up again. So like here it will, like I will successfully get my data. So this is what I mean by having a retry mechanism, and also like a circuit breaker when we, for example, we have a fallback just in case the service is like 100% or totally unavailable. Just an example, like I can fetch the data from the cache, I can just return an error message, or like do anything. All right, so this is the second, or like this is the next topic. All right, so now here, when we talk about sending a request from one microservice to another, and maybe the service is failed, or like has failed, or like is failing at some point, or like at some level of the architecture. So here this will introduce us, or like will move us to the next topic. All right, so like the next topic is, so here, distributed tracing. All right, so here we will talk about distributed tracing. So again, within the same architecture. So here we have microservice 1, microservice 2, 3, and so forth. All right. Okay. So we have the request, and here we have our API gateway, of course. And the request will go here, and then number 2, and then number 3, and then number 4, and then it will go back. All right, so like this is how our request will go. So like first, second, third, and fourth call, and all of them are HTTP calls, for example. All right, so now let's say that the application fails at this point. So like we are not able to retrieve data, or like to communicate with this microservice, or like even something happens, or like a business exception, or like something is not correct with the request that we are sending. So now what I want to do later on, so like if something is failing, all right, yeah, I just see one question. Are you going to cover security? Yeah, we will cover security just in a few seconds, well, a few moments, not seconds, because just I'm going step by step. So like I'm not burning the steps. I'm just trying to go step by step. So like I'm trying to tell you a story. So like when we talk about microservices, I'm trying to tell you a story. What is microservices, or like what this architecture that we are talking about. All right, so now we have request 1, 2, and 3, and it's failing at this point for any reason. Okay, so we don't care about the reason. So like for any reason, my request, which is this is my request, is failing at this level. So now I want to know what was the path for this request, because here we are just playing with 4 microservices, but imagine having, I don't know, like 15, 20, or like 50 microservices, which is a case, or like might be like in the big projects or like big companies, we might have this number of microservices. So now I want to know at which level or at which step my request has failed, because this will help me understand what was the problem exactly. Okay, so like I send a request, so this one is okay, this one is okay, this one is okay, this one failed. So I need to know why this one failed. All right, so how to know that? So the question here, how can I know that a specific request, so let's say that this is the request number x123, all right? So x123 has failed at the 3rd level. So like here from this diagram, I know that it failed from the 3rd level, but when it comes to like the real world or like real application, there is no way that I can know, all right? If I just debug and resend the request again and so on and so forth. But this is not something that I want to do. I just, when I receive a complaint or like a feedback from a customer that the application is failing, when I try to do this and that, so anyone should be able to figure out what was the problem. So here we mentioned that our request, let's call it x123. All right, so here in order to have in order to trace this request, so what we do, we have, or like we add this x or like this ID. So like generally or like mainly we call it x trace ID. All right, so like it's a tracing ID. All right, so this is an ID that will help me trace my request. And this trace ID, what it does, so like for each request that I will be sending, so like this one will start from the API gateway. So here, the API gateway will generate a trace ID and add it to the header of each request. Well, so like not each request technically, but it will add it to the first request. So like here, when we move from this one to this one, we will have this x123 as a header. All right. And then when we move to the next one, and so forth. So when the application or this request fails at this level, all I need to do is to pick this trace ID or this X trace ID and search for all the logs and all the flow that happened when I called or like when I sent a request with an ID or a trace ID called or like named x123. All right, so this will help me trace or like trace back or like do a backtracking from where the application has failed and then going back to the source. All right, so this helps a lot. All right, so this is about distributed tracing. Then now I will just go back to the question that I just read it differently, which is talks about how you have several microservices that need to keep data consistent across all services. However, due to a network issue, a transaction gets interrupted halfway, leaving some services with inconsistent. This is a really good question. All right, so now again, let's talk about this topic. So here so this is called Saga Pattern. All right, so let me make this one this way. So here we will talk about Saga Pattern. So again, I have microservice 1, microservice 3, 2, 3, 4, and so forth. So like the number or like the order does not matter. And here I have my API gateway here. And now again, I'm sending a request. So like I have my request here, and the request will go first to this microservice, for example, and then it will go all this way from microservice 1 to microservice 4. Again, the request will fail here. So now using the distributed tracing, I know that my request failed at this level or at this microservice for a specific reason, which doesn't really matter for now, but later on, like in the business, from business perspective or from debugging perspective, of course it matters. But here, what really matters. So here, let's say that at this level, so I create a customer. All right. So in this microservice, I'm creating a customer. Here, I'm updating the stock. So here, update stock. And now just assuming here, just send, start payment. So here I will start the payment at this level, but the payment has failed. So like the payment was not successful. So here, I don't know, like the user has put a wrong credit card or any reason. What if I do not react to this one? What will happen? So here, the stock, for example, the customer bought 3 elements, all right? So like, or 3 items. So creating a customer might be okay. So like having the customer in the database might not be a problem, but having a wrong stock within my application is something critical. All right, because for example, like imagine that these are the last 3 elements or like the last 3 items of a specific product, but user 1 or like customer 1 tried to buy it, but he did not have, or like he did not put, or like his payment was wrong or like failed, just to keep it simple. And I have a customer 2 wants to buy, all right, whether like it's 3, 2 or 1 items, one item. But here, if I do not re-update the stock, so like if I do not move the stock from -3 to +3, just to bring back what was deducted, so my system is not consistent. So in this case, what I need to do, I need to have a kind of a rollback. So here we need to talk about rolling back. So here we need to roll back the transaction. So because here, all this, we call it a transaction. So here, this one is a transaction. All right. So I need to roll back this transaction. Whether I roll back the whole transaction, so like re-updating the stock, deleting the customer, or if I say, okay, I just need to re-update the stock. So like here, it depends what I want to roll back exactly. So like it really depends on you, depends on the business requirement, and depends on the use case. So here now, how can I roll back a transaction in a microservice? Because here, sorry, I did not, I do not remember the name, but here, like it's not a full transaction because the network, for example, let's say the reason is that the network is down. So here the network is down, all right, or like even the payment. But if the network is down here, so like we have a problem, all right. So like we send the request, but the network was down, so like we don't get a response, all right. But the request was sent for a reason, anyways. So like this is not the main thing that I want to discuss. So here, what I can do. The first thing, or like one of the ways to implement this Saga pattern, all right? So like one of the ways is to have something like this. So here, when we want to start a payment, we can have a method, which, for example, called execute payment with parameters, for example. And here, in case of exception or issue, let's call it just issue, generally speaking, what I want to do, just call revoke. So this revoke stock, of course, with parameters. So this revoke stock is a method that needs to be on my stock microservice. So here I need to have a method called revoke stock. All right, so like revoke stock, let's say, for example, I mean by revoke stock is this. So like I need to call /API /v1 /stock /revoke/parameters here. All right, so I need to call this API, and this endpoint should exist on this level or on the stock microservice. So here, imagine that you have a lot of communications and a lot of microservices communicating with each other. So here we might have a lot of code to update. All right. So here we just took one example. So as I mentioned, when I execute, when I run the execute payment method, which is an endpoint, and I get an issue, I need to call another method because I know executing a payment for that, or like before that, of course, I have updated my stock. All right. So I need to revoke the stock, or like to bring back the stock. All right. And so this is one way, but this way, okay, it's fine. So like it's part of the Saga pattern. It's one way to implement this. But here, imagine if we have so many microservices communicating together. So like we have a lot of code that we need to maintain, like a method that first like will deduct the stock, and another method that needs to revoke it, to revoke the stock, or like add the stock or update the stock. You can call it whatever you want, which might be called from any other microservice. And for that, whether I need to add permissions to this revoke stock method. So let's say, for example, this method can be called only from the payment microservice, or like 1, 2, 3, or like a list of microservices that are eligible or authorized to call this method. Also, like if I want to introduce some updates, for example, if I want to change only the signature of this method, so I need to change the stock, or like redeploy the stock, and at the same time I need also to change this one. So for example, like just an example, if I want to move from v1 to v2, I need to deploy 2 microservices in order just to make everything working as before. All right, so like this also like something that we need to consider. So this is one way. Another way of implementing, or like another way to implement the Saga pattern, so we can have a queue or a message broker. So like here, I would just type Kafka because it's just easy to type. So here I might have a Kafka broker, and what I need to do is like just implementing the same thing but in a different way. All right, so like I will send, or like I will enqueue a message right here. So message, and let's say stock, and I have this microservice, or like this stock microservice connecting to this Kafka, and I will, like every time I receive a message, I will receive it, of course, with the parameters, with a lot of information. So I need to revoke my stock. All right, so like this is also another way. And of course, there are a lot, or like many other ways to implement this pattern. All right, so now okay, so now we will move a little bit to the chat. So let's start discussing, and then we will continue with maybe the last part, and then we will have the Q&A session to talk all together. So like first, like go ahead and type your messages, and I will start reading the previous ones and see if there are some messages or like comments that I need to answer. So here we have the first question is like this question is by Francisco. So like, is a circuit breaker sorry, where is it? Yeah, is a circuit breaker still necessary even when using a message broker, since we communicate with the broker instead of directly with microservice? So do we still need? Okay, so this is a good question. So in this case, what we can do, we can just implement a retry, because in case, for example, the microservice is down. So if this microservice is down, we just can just retry 2-3 times until the service, well, not so many times, of course, but until the service is up again, and we can just resend the request. All right, you're doing great job. Yeah, thank you so much. Really appreciate that. All right, as a mid-spring developer with no experience in microservices, how long will it take me to have a solid understanding of microservices? Like, to be honest, if you have the Spring knowledge, or like if you are good with the Spring framework and Spring Boot, it will not take you so long, to be honest. Like, it will not really take you so long, because just following this stream today and understanding, even rewatching this video and then watching my my Spring Boot or like my microservices video, you will have really good understanding of microservices architecture. So like, because so microservice is just a puzzle, all right, and all you need to do is just to put the elements in the correct place, all right, just connecting the puzzle elements. So this is microservices. So like, just go ahead, just try, just make your hands dirty, and you will get used to it, and you will start really learning. So like the key for that is just work. Like, you don't need to implement a huge system, just implement few microservices that communicates between, like, together. Also, like, try to set up like message broker and so on and so forth. So like, within that you will see a lot of errors, a lot of messages, a lot of exceptions, a lot of things, and with that you will start searching the internet, reading the documentation, searching for videos and so on and so forth. So like, you will learn from that, all right? So like, you will learn from that. So like, the key here is just go ahead and search, go ahead and work, go ahead and just make your hands dirty, and you will get it. So don't worry about that. All right, next question. If 10 customers add the product to their basket, what will happen after they have already paid? So here, if I get your question, we are talking here about 10 customers adding the same product and assuming the same quantity, which is the only quantity available in the stock. So here we need to handle concurrency. So like, so this is a bit an advanced. This is an advanced topic. So maybe, so like, it's not only related to microservices, but it's related to many things. So like, trying to work on the same resource from multiple threads on, because like, users we can consider them like threads. So like, we have a source and like, we have multiple users. So this, I will try to cover this one in a different stream or in a different video on my YouTube channel. Right. So next one. Hi, first I wanted to thank you for all the value you bring. Your tutorials have been very helpful. With that said, I'd like to ask if you have any plans to create a tutorial on testing in microservices, example, integration and contract testing. Additional, I'd like to know if you might consider making a course on deploying to EKS. Good question. First, like, thank you for the support. I really appreciate that. The second thing, so yeah, I have a plan of a lot of courses, a lot of things that I want to teach you guys. And to be honest, like, today I just wanted to have it as I don't know, like, as a first experience, because from now on I prefer, or like, I'm thinking about having, or like, making streams every week, and even like, we will implement an application together as a live coding. So like, every time, or like, every week we'll implement a part of it, and so on and so forth. So like, but I will also like put this, or like, I will take note about what you said. Also, like, especially testing in microservices, because this is very important. So like, this is also like a topic that I wanted to cover in today's stream, which is like integration and contract testing in microservices. But I will also like, I will try to have a dedicated session for that. So also making a course, or like, on deploying to EKS, I can also like consider that. Because okay, I will tell you about this one just in a few seconds, because let's go back maybe to the stream. And also, let me see if we have other questions. So like, just go ahead, if you have questions, just drop a comment. Otherwise, I guess we can just go back. We can just go back to our stream and to continue within our application. All right. Okay. So I guess no other questions. So the next topic is, I guess everyone is waiting for this one. All right, so guys, just let me know. Okay, yeah, please, difficult to find resources. yeah, so yeah, just to answer again, like Vin Diesel. Sorry, I'm sorry if I'm pronouncing the name incorrectly, but as I mentioned, yeah, I will try to have a dedicated session just to cover this part. All right, so now let's go back, and the next topic that I want to talk about is security within microservices. So security is an important topic. So it is very, very important no matter what the architecture. So like whether it's microservices or even any kind of application. Right. Okay, I see one important question, which is also like part of what we will talk about right now. Okay, so one question from Osama. Hello, Ali. Thank you for the effort. Yeah, my pleasure. Okay, so my question is, are you thinking about making a tutorial on how to customize Keycloak themes? All right. So this is a very, very not funny, but this is really very nice because like lately I've been thinking about well, not having a tutorial about how to customize, because I can explain that how to customize a Keycloak theme, but this requires some work. And also, like I was going to ask in a YouTube post if anyone is interested on working on an open source project just to create or to customize some or like add customizations to Keycloak theme, or like even later on working on a Keycloak theme generator. So this is yeah, this is a topic I will have a dedicated stream, so it will not be so long, but we will have something to like, or a stream to talk about that one. But yeah, this is a good point, and also like I have this on mind, and we will discuss it. We will discuss it in a dedicated stream. Okay, so maybe let me try to answer Ozar's question, because I think he needs to go. So I'll leave a question about security because I have to go. I understand that we can secure the API gateway, let's say with Keycloak and JWT. What if one microservice needs user ID from that token? Okay, I will explain that in just a few seconds. Does it mean that microservice 1 have to be secured like API gateway? If so, what if microservice is communicating with microservice 1? In that case, microservice 2 also need a token to speak with microservice 1. So yeah, this is what I will be covering just right now. All right, so here let's first seal our microservices. So like this is my private network, and here I have few microservices communicating together. All right, and here I have my API gateway. All right, of course, I receive my request in here. So this is my HTTP request, and the request will be dispatched, or like will be sent to one of the microservices, and like all the classic about that. So now I need to secure my application. So I need to secure my whole architecture. All right, so maybe let me put this, sorry. So I need to secure this. So here, like I also, like in the comments on the different videos, I saw a lot of comments saying that where do I need to put, or like where do I need to implement security? So here, like if we think about it in a logical way, what is the entry point of our architecture or of our application, or like the full application is this place right here. All right, so like this is my entry point. So first, like the first thing that I need to consider or to think about is to have a security level in here. So like here I need to have a first security level, so like it will be the first line of defense of my application. All right, so here let's say like whether using Keycloak or anything, so like this is not so important. So like Keycloak, like classic or like custom implementation of security, OAuth 2, OAuth 0, Okta, and so on and so forth. So like we don't really care about this one. All right, so like this will be the first line of defense for my application. So I need to set up a security at this level. I need to check if the user or if the client who is sending a request to my application, or like to my network, to my servers, is allowed and authorized to send a request. All right, so this is the first, as I mentioned, the first thing that I need to do. Then let's say, for example, this microservice right here has some endpoints which is only for admin. All right, so like only the admin can access some endpoint in here. All right, so what I need to do, or like all I need to do, because like it's not really complicating, and this is, by the way, this is an answer for Ozar's question. And here, all I need to do, I need to include my JWT token, or like maybe let me call it token just to avoid confusion. So like I will just need to include the token in the header. All right. So like here, I need to send the token in the header. And then when I receive this token, again, this microservice needs to communicate with my auth provider in order to validate, because like I need to validate again the token. All right, so like maybe here you will say, okay, so like we are doing a double work, or like we are doing the work 2 times and so on and so forth. But here I can just give you an example. So here, let's say now, okay, so like here, maybe let me draw it. So like here, this is my time access. So my token, so I send, so this is my token. So like my token lives in here. All right, so like this is the token expiry date, or like the token living time. So I send my request at this time. So like here, this is my request. All right, so like this is my request, and the request among, or like among all the microservices, it will take this amount of time. All right, so like here on the API gateway level, so the token is valid. So here on the API gateway level, the token is valid. So like it is valid because the request started here and the token expiry is here. So like the end date, or like the expiry date, is here. So like the token is valid, so I send it through the different microservices. So now I have my microservice number 1, for example, will receive the token here. All right, and then microservice 1, or like whatever, he will send it to another microservice at this time. And also, let's say I have this. Okay, so like microservice 1, 2, and 3, and this is like the execution time of my request. All right. So now the token just expired in here. On the API gateway level, the token was fine, was totally fine. But when the microservice 1, or like the first microservice or the first endpoint receives this token, the token just becomes expired. All right, so I need to reject the full request. So that's why for each microservice, so like don't even think, so like it's not a performance issue. So like security comes always before performance. So like having a performant application but not secure, no one will use this application. But having a high secured application, but assuming or imagining that it's not performing well, or like the performance is a bit low, for me, or like for a customer, it should be fine, or like it might be fine just to have some latency, if we might say so, just having some latency, but I'm secure. All right, I'm secure, like my data is secure, and so forth. So this is why we need to secure, or like this is why we need also to implement security on each microservice level. So here, just in case I need the token, by the way. So here, just if I have an endpoint accessible only by admin, I need to pass the token from the API gateway to the different microservices in the header. And this way I can validate the token, and I can extract the roles, the authorities, permissions, and so on and so forth, and make sure that everyone can access what he is authorized for. Sorry, like excuse me if my English is or I'm saying something wrong, because yeah, this is not my native language. Anyways, so this is the first type of security. The second one, or like another type of security, is if I want to communicate to microservices without the need of having a token. All right, so So here just microservice, let's say, I don't know, like 4 needs to communicate with microservice 6, but these two microservices, they communicate only internally. Let's say just we don't have, or like they are not on the API gateway level. All right. So here what we can implement, so like it will not be a JWT token based security, but it will be based on some API key. All right, so like here I can assign, or like I can give an API key, and they say, okay, anyone who has this API key is authorized to connect or to contact me. So like, and of course here we will again go to our auth provider, Kicklock or whatever, or like even if you want to have a custom implementation of API keys. So like this one, also we need to validate if the key is still valid, if it's not revoked, if it's still not expired maybe, and so on and so forth. So like here, there is no need to provide a password or a token. All right, so I just need an API key, and within this API key, I know that for the microservice, or like the service or the application number 6, or like with the name 6, is authorized to communicate with 4 or vice versa. All right, so this is when it comes to security. So like this is what we mean, or like what I wanted to explain about security. So what to use, like Kicklock, JWT, custom implementation, or whatever, it's really up to you. But for me, I always recommend using auth providers. All right, so here I always recommend using auth providers like Active Directory, AWS, or like AWS IAM, or like Identity and Access Management, or like Azure, or any auth provider, which will so like the main reason here, like why I always recommend using auth providers, is this will take off, or like with this release you from all the issues, or like all the things that you need like to handle or to manage users and permissions, revoking, and all this stuff. So like you don't need to take care about this. All right, it will be 100% delegated to this auth provider. Right, so maybe now we can move to the chat. I guess we can move to the chat now. Okay, so do we have, or like did I forget another topic that I need to talk about? So like first, before moving to the chat, or like we can also like move to the chat now. But before that, I would like to know, or like I would like to have a feedback from you about this stream. So like, what about this topic? Did you enjoy it? Was it helpful? Like, did you gather new information, something new? Did you learn something new today? Do you like this way, or like would you like to have more streams, weekly streams, bi-weekly streams, or something like that? Just I would like to know, because this is very important for me to be able to decide. All right, so like here I see that already Emmanuel said that we'll appreciate the weekly streams, which is fine for me. I'm happy with that. I can also like not play, but just plan that every week. So yeah. All right. So now let's start. You can start asking your questions, and maybe if something that I forgot to cover, I will just try to cover it also. Just go ahead. I'm waiting for your questions. Okay, weekly is nice. Okay, we can keep it weekly. Perfect. And by the way, I have an important announcement just before ending the stream. I have something which is very important. I will announce it to you. Okay, so what's the size of JWT and what type of data can I store on it? So for the size, to be honest, I'm not 100% sure. I don't want to give wrong answers, but you can put any kind of data, not type. Okay, so type, I mean, you can put strings, like primitive types, and so on and so forth. So this is perfectly fine. But I don't know, like, I'm not sure. To be honest, like, I never tried to put an image in a token, for example, or a video or something like that. But you can put any data you want in a token. All right, so this stream boosted me 2 years on my career. Okay, I really appreciate that. I'm really happy that you like this stream. Thank you. Are you taking payment? I don't get your question, but if you mean if I take payments directly, I would say no. But if you want to support, you can see, or like you already have the support me, or like the support link. You can support there, or like you can support directly on YouTube. I would really appreciate that. So it's really up to you guys. Like you don't have to, but I really appreciate it. Yeah, Christopher, thanks again. Thank you for the donation. I really appreciate that. Right, thanks for everything. Saludos desde. Thank you, guys. Thank you so much. I appreciate that. Can quantum computing hack bcrypt of AES encryption? Really good question. I need to buy a quantum computer first, try it, and then I can give you the answer. To be honest, I don't have an answer for that one. I don't have an answer for this question. Just, yeah. All right. Anything else, guys? Yeah, my pleasure. I'm still waiting for your question. So if everything is clear, I really... this really makes me happy. But if you have questions, just go ahead. Just go ahead. So in this video, are you going to code? Just to know. So like in this video, just I wanted to have, as I mentioned, like a deep dive into microservices, but it's not a coding. Just I wanted to highlight and explain concepts. All right. So this is what I wanted to do from this live. All right. So in the next live streaming, I will just talk about it in a few seconds before ending this stream. Okay. If the client insists on using Oracle DB in a microservice architecture with DB per service approach, would you recommend using multiple Oracle databases, or it's better to use a different setup? So for this one, it really depends on the customer or on the client. So like if he wants to use Oracle database, so like he's free to do that if he's willing to pay for it. So no worries with that. So like I think from a developer perspective, you just need to implement a good architecture. You need to implement like a well-secured application, a performant application. You need to take care of all the different things. But if the client insists or like wants to use anything, just it's up to him. Like he's paying, you're not paying for anything. Like the client or the customer is paying for the database or for the server. So like it's up to him. All right. Yeah. Thank you so much. I really appreciate it. Will you write code about what you told us? So if you are talking about the microservices, so like I already have a video on my YouTube channel, which covers everything that I explained today in deep. All right, because like when I rewatched the video, or like when I rechecked and I saw the comments, I thought maybe I missed few stuffs, but you can watch the video, and I think I can put the link, or like if any one of you, please, like, can you put the link of that video in the comments, so like everyone will know about it. All right. Well, very informative as always. Thank you, Ali, for everything you provide us. I'm glad to join your stream. Yeah, I'm really happy. Thank you so much for your inputs. And of course, yeah, I think it's successful. So like I'm happy with the output, to be honest. Like a lot of interactions, and I will consider having this stream every week. All right. Great work, keep going. Thank you so much. Can you make a stream about microservices architecture and pattern? Okay, so like I hope that I can draw like interrogation marks. So like this stream is already about microservices architecture and pattern. So like this is what we explain. Maybe you just joined the stream. I'm not mocking or saying anything bad. Maybe you just joined the stream. So this is what we spoke about since the beginning. Just rewatch the video and you will get all what you need. Yeah, thank you so much. All right, so what about how to refresh configuration from config server to all microservices when we update config server? So I already answered this question before, but I can answer it again. So here, like as I mentioned, there is some configuration on the application side, some annotations to add, and just to pull or to refresh the configuration whenever the config server gets new updates or like new configuration. So like I will try to cover it the next time, or like I will try to include it in the next video. Yeah, click to like, yeah, just go ahead, hit the like button, and I really appreciate that. Yeah, just also drop a comment, because yeah, I think I will keep the chat for the next time. So yeah. All right, any other questions? Also, like I would like to know a feedback about the video quality, about the like the voice and the audio quality, and how everything is. Also like the transition between one screen to another. Like just give me a global feedback so I can know. Also, like, what do you think about this chat pop-up and displaying your chat message on the screen? So yeah, just give me some feedback. All right, so if you don't have any other thing to add, or like new comments, I would like to go ahead with the announcement that I would like to make. So here, as I mentioned before, like I told you that I decided just to do live streaming every week, because like I think, to be honest, like I enjoyed it so much today. So we will do a live streaming every week, and I think it will be every Saturday, like almost at this time. I will also like try to update you. I will add a post on YouTube. Also, like you can follow me on Instagram. I will update you there. So I will also try to provide you with my Instagram account link. Because it's there where you can follow me and where you can get the updates when I'm going live, and also like when I'm planning the new live streams. So like this is the first thing, and I assume and I think it's very important. So yeah, here is the link. So like you can see the link now in the chat. Just let me know if you see it. All right, so like also I think I can highlight it in here. So yeah, this is my Instagram link. So like I will be posting, or like posting updates there. So this is the first thing I wanted to mention. The second thing, what we will be doing is I will, like for the next streams. So what I will be doing is I will implement an application in live coding style. So like I will be streaming every week. So like the stream length, or like how long it will be, I'm not 100% sure, to be honest, because it might be, I don't know, like maybe one day I will challenge myself and challenge you if we can do, I don't know, like 10 hours streaming, 24 hours streaming, or something like that. So like I think it's gonna be super fun if you're up to it. All right, so like we will implement an application, and to be honest, the application will be really interesting and important. So like we will see a lot of stuff. We will see like Spring Boot, of course, like Spring Boot and Java. We will see some new features of Java, Spring Boot, as I mentioned, database. We will see also caching with Redis. We will see AWS, how to upload files and data to an S3 bucket. On the front end side, it will be Angular 18 for of course, and also like even before that, I might also plan I will also try to plan another stream to talk to you about what is new in Angular and so on and so forth. So like, honestly, don't miss it with this one. And all the videos, they will be like, I will try to arrange them in a playlist so everyone can access it. So yeah, just before we finish this stream, if you still have questions, please go ahead, first of all. And second, just write me in the comments, what do you think about the quality of the video and the audio of this stream? This is very important. All right, so here I'm a recent graduate. I would love to join a big tech. Can you give me some advice? Okay, so the first advice, so this is a really good question. So the first advice I would give you, just start with algorithms and data structure. Be able, or like, try to learn how to solve algorithmic problems. So like doing lead code, code forces, advent of code, and so on and so forth. This is really important, because like when you will be, or like when you get interviewed with big tech companies, they will ask you mainly about algorithms and data structure, like for a graduated or like for a fresh level. But when you go to, okay, I think the same for mid-level, but when you go up to senior level and so on and so forth, so like it will be more of a system design and architecture question and interviews. But what I really recommend is like, just go ahead, learn algorithms and data structure, and I wish you all the success. All right, so yeah, Spring Monolith deserves some video. Okay, it's new and don't have much information about it. Yeah, this is really important. Okay, so like, also among my plans to for like Spring video, so like it will be Spring Monolith. It will be Spring Monolith. It will be also about Spring AI and like some new features that were released within Spring, which is super nice. I'm still discovering it. I'm not an expert on that yet, but I'm still discovering, reading the documentation, trying out things. But once I have something that I can demonstrate, I will also like plan a live for that, a live streaming for it. All right, so great job, man. Thank you for all your content. I really appreciate it. It's my pleasure. I really enjoy sharing content with you. So yeah. All right, mashallah alik khoya, keep the good work. Thank you so much. So like, the first part it was in, the first part it was in Arabic. So yeah, thank you. He said like, good job, keep the good work. And yeah, thank you so much, Nizar. I really appreciate it. All right, thank you all. So I guess you no longer have questions, but if you have questions, yeah, if you don't have any more questions, I guess it's time to end today's stream. So I guess thank you all for joining today. It was really a pleasure, and sorry, like in the beginning we started a bit late because I had some issues, so that's why I wasn't able to start earlier, or like at the time. But I promise in the next time it will be better. So the audio quality is great, but the camera is shaking. All right, I will try to check that. Also, like, I have the recording. I will also check if the recording is better. I will also upload the recording video. Maybe I will clean it up a little bit, but I will upload it. All right, so other than that, thank you so much. Thank you so much for watching, and don't forget, of course, to subscribe to the channel, share the video, invite your friends, share it with your friends, and thank you so much, and see you in the next time.